Hi, I'm Jonaki Ghosh and welcome to my videos on teaching calculus using GeoGebra. In this video, we shall visualize the mean value theorem. For that, let me first take you to a PowerPoint slide. So suppose we have to verify the mean value theorem for the function f of x is equal to x cubed plus x squared minus x on the interval minus 2, 1. Then we have to keep in mind two things. One, the function must be continuous over the closed interval minus 2, 1. Secondly, it must be differentiable on the open interval minus 2, 1. If these two conditions are satisfied, then there exists a point C within the interval minus 2, 1, where f dash C is equal to f of b minus f of a upon b minus a, where b happens to be 1 and a happens to be minus 2. So what does this really mean? So let me try and visualize this. So suppose I will now take you to a GeoGebra screen, enlarge it, and let me remove the axes from the graphics view, the grid at the back, and I will input the function f of x in the input bar, which is x cubed plus x squared minus x. When we press enter, we see that the function has been entered in the algebra view. Now I'm going to stretch the x and y axis a bit and move the graph towards the center of the screen to give me a better view. Now we need to evaluate the value of this function fx at the endpoints of the interval minus 2 and 1. Of course, we can do this mentally, but we can also call in a CAS window and ask for the value of the function f at minus 2, which happens to be minus 2 as well, and the value of the function at 1, which again happens to be 1. So that is interesting. Now we would like to plot the points whose coordinates are minus 2, minus 2. We notice that it is a point on the curve, and a point B which is equal to 1, 1, again a point on the curve. We can use a line option to find that segment tool and draw a line segment joining A to the point B. We could of course go to options, labeling, and only label new points so that we need not show the name of the tangent. So I'll just undo this. Right. Now let me just change the color of the, I use the selection tool and select the tangent, the segment, and change the color of the secant to red just to make it more prominent. So now we have a secant joining the points A and B on the curve. Let me now take a point A on the curve using the point tool. GeoGebra marks it as C because we already have a point A. And go to the fourth icon, the perpendicular line option, below which we will also find the tangents option. So I use this to draw a tangent to the curve at C by tapping on the point C and also on the graph. As we see now in the algebra view, the secant is named G, but the tangent is named H. And I can move the tangent along the curve. We find that if we bring the tangent somewhere here, then the tangent seems to be parallel to the secant G. And if we bring it here, then there's another position where the tangent is again parallel to the secant. So I would like to identify the specific x values where this happens. First, let me identify what is the slope of G. So maybe I could enter a function called secant slope is equal to, we say slope G. Notice that the slope of the secant is 1, and it draws a slope triangle to show that the secant is the slope of the secant is 1. Now I will do tangent slope. This is just a name, tangent slope, but I'm using the slope function within it to find the slope of the tangent h. So a triangle, slope triangle has been drawn on the tangent. We find that if we take C somewhere here, then the tangent slope is almost 0.95, close to 1. And if we bring it to the other side, again I have a position somewhere where the tangent is parallel to the secant and the slope of the tangent is close to 1. So there are 2 points within the interval -1, 2 where the tangent will be parallel to the secant joining the points A and B. Now let me solve the equation. So suppose I were to solve the equation f dash x is equal to 1, because 1 is the slope of the secant and we want to identify the point C, in this case x, which lies within the interval at which the tangent is parallel to the secant. So when I press enter, I find the two values. They're given in the form of irrational numbers. But if I change the command to nsolve, then we find that these are the two values. So let us see. One x value is if I take the tangent to around this position, so that the slope of the tangent is very close to 1, then we find that the x coordinate of the point C is minus 1.21, close to minus 1.22. And if we take the tangent to the other side, so let me take the tangent to the other side. You need to use the move tool, and we find that here again the slope is very close to 1 and the x coordinate of the point C is now 0.55. So this helps us to visualize the mean value theorem. I hope you enjoyed this video and I look forward to your feedback on the same. Thank you.